right, so here we're going to look at word problems for trig. This is the last lesson in the trig unit. We've had quite a bit of time to really kind of get our skills in terms of solving trigonometric problems, whether we're looking for a missing side or a missing angle. Remember, for each of those, there are different ways depending on the information you're given. Okay, so you might want to make yourself like a little cheat sheet or a little formula sheet. Just where it kind of outlines, okay, if this is what I have, if I have two sides and I'm looking for the third side, then I can do a Pythagorean theorem. If I've got a side and an angle, I can use trig ratios. But making a little list of those things will really help because it'll take those off the table in terms of remembering. Now, a lot of word problems will talk about this concept of the angle of elevation and depression. Now, the elevation angle is the angle made from the horizontal up to the line of sight. Okay, so both of these, so there would be an angle in here. Okay, and the angle of depression is the angle running from the horizontal down. So it would be in here. That would be your angle. As we notice, both of these angles are made with the horizontal. They are never made with the vertical. Okay, if it's made with the vertical, it is not an angle of elevation or depression. Sometimes also an angle of elevation might be called an angle of inclination. So if you think of an incline is a hill, right? Or a ramp. So it may not be a line of sight, but it may actually be a ramp or a hill, a slope of some kind. So be aware that that word might also show up, okay? Now, the reason we're learning this vocabulary is because they're often used in word problems. So we want to know what we're talking about. And the hard part about word problems is translating the language into a triangle that we can solve. Okay? Now, just to take a look here about angles of elevation and depression, if I have a man standing on a cliff, he might look up to see a plane. So that angle is made with the horizontal. Or he might look down, angle of depression, to see a boat. And that angle would be made with the horizontal looking down to the boat. So there's two different angles in there. We've got a plane and a boat. So it's important for us to kind of understand how those work. Okay? Now, I always think elevation, elevator, think up, looking up, right? And depression, oh, I'm all sad, I feel really down, so we're looking down. Okay? So, important. Okay? So how does this work? Here we have a question. It says, a ladder 8.5 meters long makes an angle of 72 degrees with the ground. So that's this. So this would be an angle of elevation because it's looking up, right? It's going up and it's made with the ground. How far up the side of the building wall will it reach? So we know the ladder is 8.5 meters. We want to find the height, and we have our angle of elevation here. Now, this is just a triangle, okay? So try not to be confused by the picture of the ladder and the building. Just look at it as a triangle. And if it helps you to draw it without the building, just as a free diagram, so I draw my triangle like so. I've got my right angle. This is H. This length is 8.5 meters. And I know that this is 72 degrees. Okay? So you're welcome to draw this picture without any of the building. When you do that, it just looks like a triangle. Now, what are we looking for? Well, we want to know how high up the building it will reach. So we're looking for H. we know the length of the ladder, and we know that angle of elevation. So now it's just a matter of solving. Now we're looking for a side, and we know an angle and a side. So we're going to have to use our trig ratios. So we're going to circle our angle, and we're going to label our sides. From this angle, H is the opposite. And 8.5 is our hypotenuse. So if we think about our SOHCAHTOA, always coming back to SOHCAHTOA, we know our opposite and our hypotenuse, so we are going to use sine. All right, so from that, sine theta will equal opposite over hypotenuse. So we'll go sine of 72 degrees equals h over 8.5. Well, it's one of the nice ones where our unknown is in the numerator, so we just have to multiply to solve, right? So when we cross multiply, we'll get 8.5 times sine of 72 degrees equals h. I'll use my calculator to figure out what sine of 72 is. Okay, so I'll have 8.5 times 0.951. It's 0.5 or 0.6. I'm going to add an extra, doesn't really matter. I'm going to actually use the whole decimal when I multiply. So I'm going to take this number and I'm going to multiply it times 8.5. So 8.5 times sine 72 is 8.08 equals the height. And it's going to be meters. Now I can round that to 8.1 meters. It hasn't indicated how many decimal spaces. The important thing to take away from this is that if the triangle is confusing in the drawing, take that picture and redraw it as a free diagram. And then it's just a matter of applying your trig rules. Okay? So there it is. Now let's do the next one. So I've got a couple of examples to go through, different kinds, to just see what's going on. So here we have, from the top of a 108-foot lighthouse, so let's highlight some information. The angle of depression of a boat at sea is 27 degrees. Find the horizontal distance from the boat to the base of the lighthouse to the nearest foot. Now here's an interesting thing. When you have this set up and we have our angle of depression here, it is the same amount as the angle of elevation below. Okay, so that means if it's 27 up here, it's going to be 27 degrees down here. The other information we know is that the lighthouse is 108 feet. Okay, and this would be a right angle. So we want to know the horizontal distance from the boat to the base of the lighthouse to the nearest foot. So we're looking for that distance here. We want to know how far away the boat is from the lighthouse. So let's take this and let's sketch it out as a free triangle. So I'll put in my right angle. This is 108. I'll remember it's 108 feet. This is 27. I'm going to redraw that because that kind of looks bad. It's 27 degrees. And I'm looking for x. Now we just have to solve for x. Now it's finding a side. We know an angle and another side, so we have to use our trig ratios. So circle your angle. From this is opposite, and this is adjacent. So if I think about my SOHCAHTOA, I'm going to use tan. So tan theta equals opposite over adjacent. So tan of 27 degrees equals 108 over x. Now this is one that's on the bottom, so that's a cross multiply and divide, right? Multiply and divide. So I will get x is equal to 108 times 1 divided by tan of 27 degrees. 108 times 1 is just 108, and tan 27 degrees is 0.5095. Okay, so we're just going to divide 108 divided by tan of 27, and I get 211.96. Now it says to the nearest foot, right? So that would be 212 feet. Okay. Now often we would write a sentence. So we would say the boat, therefore the boat is 212 feet from the lighthouse horizontally. Important to say horizontally because if we were going on that slanted height, it would be a different height. Okay? We could have written a sentence up here as well, right? So remember, it's always good with a word problem to write a sentence. On our quizzes, you're just going to write me the number, but it's good practice to remember that you should write a sentence. Now here's one where we haven't got a picture. So that's the thing, we're going to have to draw our picture. So let's read the question first. A flagpole is 18 feet tall. Andy is standing 12 feet away looking up. Okay, so Andy hanging around 12 feet away looking up. Find to the nearest degree the angle of elevation from Andy to the top of the flagpole. So let's draw that triangle. We have our flagpole. Okay. So there's our flagpole, and it's 18 feet. Andy is standing 12 feet away. Okay, and he's looking up to the top of the flagpole. Now, we're not going to worry about how tall Andy is. We're just going to, not worry about that. Okay, and he's 12 feet away. What he wants to know is the angle of elevation. So the angle of elevation is going to be in here. So we're looking for that angle, okay? Because that's the angle made with the horizontal looking up, okay? So that is our angle of elevation, and that's what we want to find out. So we circle our angle. We're looking for an angle. We know two sides. So we can't use the angle sum rule. We have to use trig. So let's label. Across is opposite, and right next to it is adjacent. So, thinking about SOHCAHTOA, we have opposite and adjacent, so we're going to use tan. So, tan theta equals opposite over adjacent. So, tan of x equals 18 over 12. We're looking for the angle, so we're going to use our second function. So tan negative 1 of 18 over 12. So it'll be tan negative 1. 18 divided by 12 is 1.5. So second function tan, I get 56.3 degrees. Now it says to the nearest degree, so I would round that to 56 degrees. So you could write a sentence, therefore, the angle of elevation is 56 degrees. Okay? All right. Let's do one more example. Hard part is drawing the picture, figuring that out, but you guys can do it. I know you can. Look at, I just want to draw in a little, I wanted it to be a Canadian flag, so I want to draw that in. Okay. I feel better now. All right. So hard part's drawing the triangle, but we have to be able to translate it because these kinds of questions are going to come up. Okay. So a lifeguard peers down at a swimming pool from a tower. So he's sitting up in a lifeguard tower. Their line of sight from the tower to the swimmer is at a 55-degree angle. The tower sits at a height of 10 feet. How far is the swimmer from a base to the lifeguard tower? So let's draw our picture. So we got our lifeguard up here in his chair or her chair. We don't know if it's a guy or a girl. He's watching, okay? Give him a little ball cap, right? There's his big lifeguard tower. And there's a swimming pool. Oh, I don't want it to be that big because I want to be able to do work. So there's a swimming pool here. Okay. All right. And there's a swimmer in the swimming pool. Okay. So we have somebody swimming, kicking their feet in the swimming pool. Now it says the line of sight from this tower to the swimmer is at a 50-degree angle. Now he's looking down. So that line of sight, it's an angle of depression, so that would be 55 degrees in there. Now, that means this is 55 degrees, or the other thing you can think about is if this is a right angle, 90 minus 55, this is 45 degrees. Okay, and think about that. 55 plus 45, is it 45 or no, it's 35, sorry. Mrs. Finley did some wrong math there. It's 35 degrees. Because 35 plus 55 equals 90. This would be our right angle. So that would be our picture. Now the tower is 10 feet tall. And we want to know how far is the swimmer from the base of the lifeguard tower. Okay, so we want to know this distance x, right? So let's redraw this and make a new triangle. Okay, so I've got my triangle like so. X, 10, 35 degrees or 55 degrees, doesn't matter which one. And we're looking for x. Now, I'm going to use the 55 because it was given, just in case I did an error figuring out the 35, like I did the first time. Okay, so this side is opposite, and this side is adjacent. Okay, so I'm going to use tan, which I already did because of TOA, right? Opposite and adjacent. So tan theta is equal to opposite over adjacent. So tan of 55 degrees is equal to 10 over x. Now I'm going to have to do my cross multiply and divide, right? So x is equal to 10 times 1 divided by tan of 55 degrees. So x is equal to 10 divided by tan of 55 degrees, or if I figure out tan of 55 tan is divided by 1.4281. So x would equal 7.00. Okay, and it hasn't given us a restriction, 7.00, so we'll just say x is equal to 7 feet. And you could say the swimmer is 10 feet, or 7 feet, ooh, catch myself fast, 7 feet from the lifeguard tower. I'm just going to write tower because of room, okay? So that would be your sentence. You can write a better sentence than I can. So as you see, the trig itself is no different than what we've been doing. We've been doing these trig questions. I've been making you do a ton of them. Now you're going to do the interpretation. Some of these will have pictures and some of them won't. So the hard part for many of you is going to be interpreting the information into a picture and then translating that into a triangle. So if you need help, just ask and we'll work through a bunch of these. But there are quite a few of them because we want to practice. There's also another worksheet as well. Okay, but there is an answer key at the end there, so you can check and see if you're getting them right. Alrighty? Okay.